What's up, guys? Today we're going to be talking about logarithms. And logarithms are kind of a new type of function. They're the inverse of an exponential function. So the first example I have here, this is sort of the form of an exponential function. You may say y equals b to the x power. And we should be familiar with how that works. Well, it's equivalent to making the statement log base b of y equals x. Okay, they're actually inverses of each other. So to give you an example, 8 is equal to 2 to the third power. If you raise 2 to the third, you get 8. Okay? Well, that's equivalent to saying log base 2 of 8 equals 3. So in other words, if you look, the base of the exponent is also the base of the logarithm, but the other two numbers have kind of switched. Above the 2 is now the 8, and the 3 moved to the other side. So when you're rewriting from one to the other, if you have an exponential function, the base is still the base here. So the base of the exponent is the base of the logarithm, and then the other two numbers kind of switch. The number above the base switches, and then the other number goes to the other side. So here's how you read a logarithm, okay? Log base 2 of 8 equals 3. What that says is, if I cover this up, what power of 2 is going to give me 8? And the answer is 3, okay? What power of 2 gives me 8? That's what logarithms ask. What power of 2 gives me 8? And the answer is 3. It's similar to when you're doing division. You may say 8 divided by 4 equals 2. That's true, right? Well, it's the same as saying, what do I multiply 4 by to get 8? The answer is 2. So the same way I can rewrite a division problem as a multiplication problem, I can rewrite an exponential equation as a logarithmic equation. Okay, so first let's solve a few logarithms. Let's look at some examples of logarithms and let's see if you can figure out what they would be, okay? Just do some examples. All right, so if I said log base 5 of 25, what would that be? So what power of 5 will give me 25? The answer is 2. What power of 5 gives me 25? 5 squared equals 25. Okay? Another example. Log base 4 of 64. What would that be? What power of 4 would give me 64? 4 squared is 16. 16 times 4 is 64. So the answer is 3. So the reason why is because 4 to the third equals 64. Just like over here, 5 squared equals 25. Okay, sometimes the examples make it a little bit trickier. They may ask you to evaluate a logarithm that's a little bit trickier. Like, for example, if I say log base 2 of 1/4. Sometimes we put it in parentheses. Doesn't really matter, but log base 2 of 1/4. What would that be? What power of 2 gives me 1/4? Well, 2 squared is 4. And if I use a negative exponent, it will flip my base. So I need to flip it clearly because it's going to be a fraction, 1/4. And I need to square it because I need the 2 to become a 4. So the answer is -2. Again, that's because 2 to the negative second power is equal to 1/4. Another tricky example sometimes, and it actually turns out to be very simple, is when you see something like this. Log base, let's say 5, of 5 to the, let's say, third. Log base 5 of 5 to the third power. Now you might think, wow, that's crazy. There's so much going on there. Think about what it's saying. And you might need to pause and rewind it a few times here. What power of 5? What power of 5 gives me 5 to the third power? Go ahead, pause it, rewind it, listen to that a few times. The answer is 3. What power of 5 gives me 5 to the third power? 3. Why? Because here's what I'm saying. What power of 5 gives me 5 to the third power? Well, when you write it that way, it's pretty obvious, isn't it? What power of 5 gives me 5 to the third power? Of course, it is 3. Okay, 5 to the third is 5 to the third. So let's say that again. What power of 5 gives me 5 to the third power? 3. Just kind of a trick question that people like to ask sometimes. Sometimes you'll be asked to solve a logarithmic equation like this, where the unknown is actually the base of the logarithm in this case. And so again, what are we asking? What power of x gives me 100? And the answer is 2. So another way to think about this is to actually go ahead and rewrite it. What they're saying here is that x squared equals 100. By rewriting the logarithm as an exponent, again, the base stays the same, the other two numbers kind of switch places. X squared equals 100. I think at this point it's clear what the answer is. The answer is 10. Now, some rules of logarithms that I didn't mention right at the beginning. The base of a logarithm has to be positive. It can't be negative. It also can't be 1. So it's the same rules that we had for an exponential function. You can't, since it's the same thing flipped around, it follows the same rules. The base follows the same rules as the base of an exponent. It can't be negative, which is why we didn't say plus or minus 10. And it can't be 1 either, because it wouldn't be very interesting. 1 to any power is itself. One final thing we have to talk about with logarithms is the idea of a common logarithm. A common logarithm is kind of like thinking about a square root. We learned about a lot of different roots, but remember that the square root we only had to write like this. We didn't have to put any kind of number there. If it was a third root, we'd put a 3, or a fourth root, we'd put a 4. But for a square root, we just write this, and everybody knows we're talking about a square root. Well, when it comes to a common logarithm, if you don't put a base, what that means is that the base is actually 10. So log x is actually the same thing as saying log base 10 of x. And we can use this to solve certain problems because this button is a button on your calculator. I have one right here, and the multi-views have it as well. If you look right here, there's a button that says log, L-O-G. And that button will actually do common logarithms. Okay, so here's an example problem. Suppose someone says 10 to the x equals 13. How can we solve this? Well, without logarithms, this is pretty hard. You almost have to kind of guess and check different numbers you can plug in for x to get 13. 10 to the first power is 10, so that's too small. 10 to the second power is 100, so that's way too big. So the answer must be somewhere between 1 and 2, but we don't really know what it is. So what you want to do in cases like this is you want to rewrite the problem as a logarithm. If I rewrite this as a logarithm, then I can say log base 10, which remember I don't really need to write. I'll write it this time, but I don't normally need to do this. And the other two switch places. Log base 10 of 13 equals x. Okay. Well, log base 10 is actually just log 13. Okay, we don't really need to write that 10, and this is a button in our calculator. So I'll show you how to solve that. Okay, so to do this in our calculator, all we need to do first of all is hit the log button, which is right here. And we're going to type in 13. So we can take log 13, press enter. And there's the answer, 1.11, which as we said, it's somewhere between 1 and 2. And you can even think a little further. It's closer to 1 than it is to 2, because 13 is much closer to 10 than it is to 100. So we knew it was somewhere between 10 to the first power and 10 to the second power, probably closer to 10 to the first power. And as you see here, that was the case. It's 1.11. Okay, finally, one more example. There's a few more algebra steps we need to do in this problem before we can solve it like we did the last one. But what we want to do is get 10 to the x by itself. So first I need to add 100 to both sides. When I add 100, I get 460 on the right side. And now I need to divide both sides by 5. And so I put that in my calculator. And 460 divided by 5 is 92. Now that I have just 10 to the x power on one side, I can rewrite this as a logarithm. So we know that x is equal to, and I put this in my calculator, I put log 92 on my calculator, and I get 1.96. Okay, and this answer, as we saw before, was 1.11. And so that's it.